All right, today we're talking about the discriminant. And so we're actually looking at part of the equation that we would use to solve a quadratic. So it's part of the quadratic equation. And it's actually the part inside the square root sign, which tells us the distance from the center or the vertex of a parabola over to the roots. So the discriminant is actually significant because it lets us know what type of roots, or as it's referred to, what is the nature of the roots. So when I refer to the nature of the roots, there's one of two things that can happen. I can get roots that are real, or I can get roots that are complex. Complex includes some imaginary part. I can also get roots that are rational, or I can get roots that are irrational. So I'll give you a little bit of insight as to exactly what that means with a couple of examples. So this discriminant, the green part, the discriminant, we could calculate using this part of the quadratic formula. So if I was solving this with the quadratic formula, then I would look at b squared minus 4ac. So our b value is negative 4. So I would get minus 4 squared minus 4, our a value is 3, and our c value is 1. So negative 4 squared would be 16, and 4 times 3 times 1 is 12, which means this discriminant is actually worth 4. So if we can imagine what that would look like in the problem we would have this square root of 4. Well, 4 is as nice of a number as we could come up with. It's actually a perfect square, and it's also positive. So this root, whatever happens over here, doesn't really affect the type of root we're going to get. This is going to come out and be really nice. So this answer, because it's a perfect square and because it is positive, is going to be real, and it is also going to be very rational, which means it's going to be very nice. It's not going to have a square root in it. It's not going to be crazy looking. It's going to be straightforward, 3, 1/2, whatever, a nice, even, rational number. Let's take a look at the second one. Second one, same thing. We have b squared minus 4ac. That's our formula for the discriminant, b squared minus 4ac. So my value for b here is negative 3. Minus 4a is 1, and c is 5. And you can see what's going to happen here. Because our b value, b squared, is only 9, when we go to subtract this 20, we're going to be left with negative 11. So negative 11 is inside a square root sign. That's not good. So when we have negative 11 inside a root sign, because it's negative, we know for a fact that this is going to be a complex number, not a real number. We're going to have an I taken out. And because that 11 is not a perfect square, we're going to have an irrational number. Okay, which means we're going to have a square root of 11 somewhere in our answer. Let's take a look at our third example. Same thing. So we have b squared, which is 4 squared, minus 4a, and now our c value is negative 3, and this is the one that catches a lot of students. 4 squared is 16, and be careful, make sure you realize that these two minus signs are going to get together and make plus 12. So plus 12 would be 28. So we would be looking at what? The square root of 28. Well, 28 is not a perfect square. So since it's not a perfect square, we know it's not going to be a nice, pretty, rational number. It's definitely going to be irrational. But since it is positive, and we do know we have a positive answer, then it is definitely going to be real. All right, last one. We have x squared plus 6x plus 8. So our b value is 6 minus 4a, and our c value is going to be 8. So we're going to have 36 minus 4 times 8, which is 32. So once again, that's going to give us a grand total for our discriminant of 4. So we're talking about the square root of 4. So this is just like it was on number 1. We have a perfect square. It is positive. Therefore, we have a real, rational root. So these are what our roots are right here. All right, So let's summarize it. Let's put it all together just real quick, just to remind you what it looks like. So for our discriminant, and we are talking specifically about b squared minus 4ac, if that value turns out to be positive, it is a real root. If that value turns out to be negative, it is an imaginary complex root. So that's one choice. Here's choice 1. Choice 2, I have to pick between these two. Is it rational or irrational? Well, if it's a perfect square, it's going to be rational. And if it's not a perfect square, then it's going to be irrational. And those are the two choices and the two possibilities for each.